Hello everyone. In this video, I want to talk about how we can find the domain of a function. Now, the first thing, a domain, what that is it's everything that's in our initial set that we begin with. So it's all of our possible inputs into our function. Now, we have a couple different ways that we can find the domain. One of those is maybe it's given to us. Maybe our inputs is a finite set, and we can just list off all the possibilities. Another way is maybe we're given a graph. On that graph, we can see what are the possibilities, and we can list them out, or maybe we can express that in another way. Sometimes, like I have on the screen here, we are just given the function written in function notation as an equation. Now, to find the domain of this is what we call the implied domain. So, when I look at this, I'm assuming that we are dealing with the real numbers. Maybe this is something I want to graph. So to find the domain, what I need to think about is, are there any restrictions on my equation? Is there anything that I can't do? Are there any real numbers that won't work in my rule? So let's take a look at each of these and talk about the restrictions. So the first one, f of x is equal to x squared plus 5x. So my variable x, and I'm going to do a couple different things to it. First, I'm going to take x and I'm going to square that. Now, is there any restrictions on that piece? No. I can take any real number I want, I can square it, and I'll end up with another real number. The same thing goes for 5x. I can take any real number I want, plug that in for x, multiply it by 5, and I will end up with another real number. So my domain, so I'm going to say capital D for domain, and one way I could write this out is I could just say that my domain is all reals. Now, a second way I can describe my domain is by using interval notation, and this is usually the preferred way. So interval notation, I'm just going to describe the interval of possible numbers. In this case, all real numbers, this is everything that goes from negative infinity all the way to positive infinity. Every single number. Okay, let's take a look at the second one. Here in the second one, g of x is equal to the square root of 4 minus 3x. So I do have a new operation in here. I have a square root sign. Again, we just need to think about what sort of restrictions we have for our real numbers. I know that with square roots, if I want to ensure that I always have real numbers, my radicand, anything that's underneath the square root sign, this has to be 0 or it has to be positive. If I try and take the square root of a negative, I end up with an imaginary number, and we don't want that. So I'm going to set up a little inequality to ensure that we end up with something that's non-negative. So the radicand, 4 minus 3x, everything underneath the square root sign, this has to be greater than or equal to 0. Just making sure that it's not negative. We can solve this inequality. I'm going to add 3x over to the other side. 3x on the other side, and that's going to give me 4 is greater than or equal to 3x. And to finish up, we'll divide both sides by 3. And I normally like having my x on the left-hand side. So then x, just making sure that my inequality sign stays pointing towards the x, we end up with x is less than or equal to 4/3. So solving that inequality, what that tells me is that as long as I pick out any real number that is 4/3 or smaller than 4/3, this function will give me something that is a real number. So then to describe this as a domain, in interval notation, everything smaller than or equal to 4/3. So that is going to include everything from negative infinity. Then we're going to go all the way up to positive 4/3. And this does have the or equal to part. So to indicate that, we'll use a square bracket. That means that we are going to include 4/3. Okay, and the last one. The last one deals with the last restriction we're going to come across mainly. In this case, h of x is equal to 3x over x squared minus 4. So written as a fraction is just division. So again, thinking about the restrictions we have, I know I can't divide by 0. It gives me something that's undefined. Undefined isn't a real number. So we just need to make sure that whatever we plug in will not make my denominator 0. So I can express that as, so x squared minus 4, that expression, we do not want that to be 0. And when I solve this, this is going to tell me my numbers that are excluded. So adding 4 to both sides, we know that x squared cannot be 4. And then taking the square root of both of these. And we do need that positive negative, so x cannot be positive or negative 2. Right? So to express that as a domain, it can be everything but these two numbers. So maybe I'll say my domain is all reals. And here I can maybe I'll use the symbol for real numbers. It's the double barred R. And then I could just say except x cannot be 2, it cannot be negative 2. Now the other way I can express this, if I wanted to use interval notation, so I just have everything except these two numbers. So we can go all the way from negative infinity all the way up to negative 2, where we have to stop. We don't want negative 2, so I'll use a parentheses. And then we're going to pick right back up on the other side. And to do that, I'm going to use a union. So that means and. And we can go from negative 2, we can go all the way up to positive 2, but we have to stop there again. And then lastly, we'll pick up on the other side with another union. So we'll jump back to 2, all the way up to positive infinity. So those are the main cases. Thinking about the restrictions we have on real numbers. We know we can't take the square root of a negative. That also applies for any even root. So if we're trying to take the 4th root, the 6th root, etc. And we just need to worry about division. We want to make sure that we're not dividing by 0, otherwise we'll end up with an undefined number. Thanks.